Okay, hi everybody. Today we're going to talk about properties of exponents. Now, I know this isn't going to be the best way to look at this or do this, but hopefully the video is good enough that you can see and understand what's going on. Okay, so properties of exponents, you talked about these back in Algebra 1. So this should be a bit of a refresher and a review for you, but it's going to be something that we need as we continue on in this chapter. We're going to need to use these properties to do some other things. Okay, so let's suppose that we have two. I'm going to give you the rules and we'll do a simple example of each one, and then we'll do some more complicated examples. So let's suppose that you are multiplying two powers together. Remember, when we're talking about exponents, this number, the a, is considered the base, and then the m, or the n, depending on which one we're looking at, is the exponent. And the whole thing together, a to the m or a to the n, is called the power. So this whole thing is the power. Okay, so just a little vocab, because I like correct vocab. So I'm going to rewrite that again so that it's not have all that drawing all over it. But let's say that we're multiplying two powers together, and notice that the bases are the same, right? So if we multiply two powers together when the bases are the same, remember that the base doesn't change, and all we're going to do with our exponents is add those two together. So that's going to become a to the m plus n. Okay, what happens if we are dividing two powers with the same base? So if we are dividing a to the m by a to the n, again, the bases are the same, so the base doesn't change. And this time, instead of adding our exponents, we will subtract them. Okay, just number these, I guess, as I go. So those are the first two. The next one, if we have a to the m, and then we're going to raise that to another power. So if we raise a power to a power, then we're going to take our exponents and multiply those two together. So that would become a to the m times n. All right. If we have, let's say, for example, let's divide. Let's do this instead. Let's say we have a times b to the m. So now we have more than one base inside the parentheses, and we're raising that whole product to the mth power. We're just going to raise both the a and the b to whatever the exponent is on the outside. And if there were more than just an a and a b, if you had abc or abcd or whatever the case was, you would just raise everything in those parentheses to that power. So this would become a to the m times b to the m, I'm sorry. Excuse me. Excuse me again. Okay, the same also works if you are dividing. So if you have a divided by b to the m, then we can separate that as both a to the m in the numerator and then b to the m in the denominator. So it works for both multiplication and division. You're just going to raise everything in the parentheses to that power. Okay, two more. So let's say you raise a to the 0. Remember that anything to the 0 power, doesn't matter what it is, well, except for 0, but anything other than 0 to the 0 power is always, always, always going to be, I'll let you think for a second. Some of you are shouting out numbers, I hope, is always equal to 1, right? And this is true as long as a is not equal to 0. Okay, and then our very last property deals with a negative exponent. So let's say we had a to the negative n. In order to make that a positive exponent, because we always want to write our exponents as positive values. Why? I couldn't tell you, because somebody decided that was a smarter idea. So to make this a positive exponent, we're going to rewrite it as 1 over a to the n. So we're just going to move that down to the denominator. And here's a little trick for negative exponents. Anytime you have a negative exponent, you're always just going to move it to the opposite of where it was. So notice here it's in, right now, the numerator, right? Because this is really over 1. So to make it a positive, we just moved that to the denominator, right? What would happen if it were in the denominator to begin with? So let's say you had 1 over a to the negative n. Well, I'm going to do it the long way, and then we'll talk about the shortcut. So I know that a to the negative n is just 1 over a to the n, right? Just using that property that we just said here. Now, if we're going to divide this, in order to divide a fraction, remember that dividing by a fraction is the same as multiplying it by the reciprocal, right? And then if we multiply straight across, we just get a to the n over 1, which is just a to the n, right? So think about what's the relationship between what we started with and what's the answer. So originally, that negative exponent was in the denominator, and what happened? It moved up to the numerator, right? As we can see here better, I think. So no matter where your negative exponent is, to make it positive, you're always just going to move it to the opposite location, okay? So if it's in the numerator to begin with, it'll go to the denominator and become positive. If it's in the denominator and it's negative, it'll just move up to the numerator and become positive, okay? So you don't have to go through that long process every time. It's a matter of just flipping it. But we'll do some examples and I'll show you a little bit more. Let's just do a really simple example for each one of these, and then we'll go back and do a few that are a little more complicated. So I'm just going to write them next to these in a different color. Let's say you had x to the 7th times x to the 4th. Okay, so we can see that we've got the case here in this first example, right? This first property. Our bases are the same. In this case, the base is just x. And we've got our two exponents, m and n, right? So what does our rule tell us we're going to do with those two exponents? We're simply going to add them together. Does that base change? Nope. So our base is still going to be x, and our exponent will be 11, because we just added the 7 and the 4. Okay? Let's try one for the division. Let's say you had x to the 8th divided by x to the negative 2nd. Okay, so here's one thing that I should say is that there's a lot of different ways that you can do these problems, and whatever your brain thinks of first is okay. Well, hopefully, but there's more than one way to go about doing the problem. So it's a matter of what your brain sees. A lot of times people are going to see that negative exponent and automatically want to start moving negative exponents around. Personally, most of the time I don't do that, because you move things and then unmove them, and you're doing a lot of moving back and forth, and it can get kind of confusing. So for me, if I see this, since I'm dividing two powers, right? We're dividing the x to the 8th by x to the negative 2nd. The bases are the same, right? Still x. What are we going to do with our two exponents? We're going to subtract them. So this becomes x to the 8 minus negative 2. And then we'll just combine those, simplify here. So 8 minus negative 2 becomes plus, right? And so then we're left with x to the 8 plus 2 is just 10. All right. Let's try one for this. Let's say we had y squared to the 5th. Okay? So we've got our base, which now is y. Our m is just 2, and our n is 5. What's our rule? If we're raising a power to a power, we're simply going to multiply our exponents. So if we multiply our exponents here, we get 2 times 5, which is just 10. Okay? All right, how about property 4? So this could be something like, let's do it with a number, because I think that's where people get confused a lot. Let's say you had 2x to the 3rd. Okay, so based on our property, we've got to raise both the 2 to the 3rd power and the x. So this is really going to be 2 to the 3rd times x to the 3rd. All right, now what is 2 cubed? 2 cubed, remember, is just 2 times 2 times 2, which is 8. So we're left with 8x cubed. A lot of times when using this property, if there's more than one variable, that doesn't seem to be confusing, but it's when we have that coefficient. Don't forget, if it's just a number, you've got to raise that number to the power as well, okay? Property 5, let's say we had x over y to the 5th. Okay, so again, since we're dividing and we're raising that whole quotient to the mth power, which in this case is 5, we're just going to raise both the numerator and denominator. So this will be x to the 5th over y to the 5th. Okay, how about 6? Let's say we had 3xy all to the 0. It doesn't matter what we have in the parentheses here. If this is 0, we know that this whole thing is just going to turn into 1. Okay? And then let's say for our last one here, let's say we had x to the negative third. So if we wanted to make that a positive exponent, we would rewrite that as 1 over x to the third. And another thing to be careful of with this one, let me erase this, but another thing to be careful of with this one is, let's say you had 2x to the negative third. All right, what are we actually raising to the negative third power here? All right, in this case, we're only raising x to the negative third. So there's a difference between what I've written here and if we had parentheses around it like this. Okay, in this case, we would have to raise both the x and the 2 to the negative third. In this case, we're doing this part first, and then we're multiplying it by 2. So when we rewrote this as a positive exponent, the 2 would stay on top, and we'd move just that x to the third to the denominator. Okay? Whereas in this case, if I switch, in this case, we would raise 2 to the negative third and x to the negative third, which would become 1 over 2 cubed times x cubed, would just be 1 over 8x to the third. Okay, so hopefully you can see the difference between those two, no parentheses versus the parentheses. And we'll do some more examples, but that was just a little something so that you're aware of. Okay, so those are our basic properties. On their own, if the problems are that simple, it's not really that bad, right? You figure out which property you're using, either add, subtract, divide, whatever. Obviously, once we start combining those properties and putting more than one property into a problem, that's when things can get a little bit trickier. Just what you were hoping for, right? Okay, so let's just do a couple of quick examples of those that are a little bit harder, and then I'll let you try some on your own. Okay, so let's say that we have x squared times y to the negative third all to the negative second. Okay, so again, like I said, there's oftentimes more than one way to do the problem, right? Depending on what your brain sees first. So we've got those negative exponents, but I'm really going to strongly say or encourage you not to try and rewrite them as positive exponents right away, because it does tend to get really messy. Okay, so for me, when I look at this, I see that I'm multiplying x squared times y to the negative third, and then I'm raising that whole thing to the negative second. So what that means we're going to do, since we've got a product inside, is we're going to raise this to the negative second, so the x squared, and we're going to raise the y to the negative third as well. So if we do that, that will become x squared to the negative second and y to the negative third to the negative second. Now, you certainly don't have to write out all these steps every time. I'm just doing it so that hopefully it helps you to see where all the numbers are coming from. Okay, we said at the beginning, one of our properties, if we're raising a power to a power, right? So this is like a to the m to the n. If we're raising a power to a power, so this was the third property that we did. What are we going to do with our exponents? You are correct. We are going to multiply here and here. All right, so if we do that, this becomes x to the negative fourth. And then if we multiply negative 3 times negative 2, that becomes, so negative times negative, don't forget, is positive 6. Okay, so far so good, hopefully. Now, one thing that I didn't mention yet, but kind of alluded to a little bit, is that we're always going to write our answers using positive exponents only. Okay, so right now we have a negative exponent, one of them. We need to make that one positive. So we want to figure out which one we're going to move. Are we going to move one? Are we going to move both? How's that going to look? So anything with a negative exponent, remember we said is going to move. If it was in the numerator, we'll move it to the denominator. If it's in the denominator, we'll move it to the numerator. If it already has a positive exponent, we're just going to leave it. So we're going to leave the y to the sixth because that exponent is positive. And we're going to take x to the negative fourth, and we're going to move that to the denominator, and that turns that 4 from a negative 4 to a positive 4. Now all of my exponents are positive. I only have one x and one y as a base. So that would be my final answer. All right, so let's try another. Get rid of that one. I'll do one more and then I'll give you one, and you can pause if you want and try that one on your own and see how you do. I'll go through it and then you can compare your answer. How about, let's try this one together. How about 5x to the 5th, y to the negative 3rd, all over 10x to the negative 1st times y to the 7th. Okay, so again, depends on what you see and how you want to go about solving this. Let's start with the numbers in front. So we have a 5 here and a 10 here. Those are not powers, right? Because there are no exponents. So that's just like saying we have 5 over 10. Well, we can reduce that fraction, right? What number goes into both 5 and 10? 5 does, right? How many times does 5 go into 5? Once. And how many times does 5 go into 10? Twice, right? Okay, so we're going to reduce that fraction. Now we're going to simplify our exponents. So again, I'm not going to move the negatives around because my brain doesn't want me to, but if yours does, that's totally fine too. So I'm going to take these two and combine these, right? Because they both have the same base. In this case, my base is x, so I can combine these exponents. So we said at the beginning that if we're dividing two powers with the same base, what are we going to do with our exponents? Hopefully you said subtract. So if we subtract 5 minus negative 1, be careful with those negatives, that's going to become positive, right? And so we're left with 5 plus 1, which is just 6, right? So that means we have x to the 6th. And when you're subtracting, that is always going to go in the numerator, okay? If it turns out to be negative, we'll move it later. But it's always, always, always going to go in the numerator when you're subtracting, okay? All right, let's try combining the y's. So if we have y to the negative 3rd divided by y to the 7th, again, we're dividing, so we will do what with our exponents? Okay, again, we're going to subtract, just like we did for the x's. So this time we're going to subtract negative 3 minus 7. So negative 3 minus 7 is negative 10. All right, so where is that y to the negative 10 going to be? It's going to be in the numerator. Again, when we subtract, always, 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 whoops, I forgot the negative. Always, 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 always in the numerator, okay? All right, so now, are we done? A couple of things. Do I need this 1 in front? Since we're multiplying them all together, I don't. If you like it there, you can leave it, but it's not necessary. All right, is there anything else that we need to fix? All right, so again, remember we're looking for negative exponents if we have any, because we have to make them positive. So in this case, we're only going to move one of our variables again. Which variable do we want to move? We are going to move the y because that one has the negative exponent. So I'm going to leave the x to the 6th in the numerator, and I'm going to move that y to the 10th down. And so we're left with x to the 6th over 2y to the 10th. Okay? And that is our final answer. Let's just say though that just for another example so that you can see, let's say we had, let's say those were both negative, right? They're obviously not, and this is a separate thing, but just so you can see if they both are. So if these are both negative, we would have to move both of them to the denominator, right? So this would become 2x to the 6th, y to the 10th in the denominator. Well, what are we left with then in the numerator, right? Think back to that original property, right? When we had a to the negative n equals, we moved the a to the n to the bottom, what were we left with in the numerator? That was just a 1, right? So if we move everything from the top to the bottom, that would just become 1 over 2x to the 6th, y to the 10th. Okay, good with that one? All right, awesome. Let's try one more. So I'm going to write it up here, and then if you want to hit pause and try it yourself to see if you can get it right. And then when you're finished, go back and finish, and I will show you how to do it. I'll walk you through just like I did the others, just to see if you got the answer correct. Okay, so let's suppose we have x to the 8th y divided by x to the negative 1st, y to the 4th, all to the negative 2nd. Okay, So again, if you want to try it, hit pause here and give yourself an opportunity to try and solve this one on your own, and then see if you get the same answer that I'm going to get when we do it together. Okay, so here we go. Again, more than one way you can do this depending on what you see. Since we're raising a whole fraction to the negative second, we could raise everything inside to the negative second, right? Or we could simplify inside first and then raise it to the negative second. So totally a matter of what you see. I'm going to say that many of you probably wanted to raise everything to the negative second first. So let's just go ahead and do that. So we're going to take x to the 8th and raise that to the negative second. We're going to take y and raise that to the negative second. In the denominator, we're going to raise both our x and our y to the negative second. Okay, now, what did we say we're going to do with exponents when we raise a power to a power? So what are we going to do with these? Oops, we'll come back to that one in a second. But what are we going to do with all of those? We are going to multiply. All right, so the question is, before we do that, what's my exponent here on the inside? So if this is just y, what am I going to multiply the negative 2 with? So remember, if there's no exponent there, that's really just a 1, right? So when we multiply, we're going to multiply negative 2 times positive 1. Okay, so let's go ahead and multiply. If we multiply 8 times negative 2, that's still going to be an x. 8 times negative 2 is negative 16. Times y to the 1 times negative 2 is negative 2. And then in the denominator, negative 1 times negative 2 is 2. And 4 times negative 2 is negative 8. Okay, so again, we're not finished, right? Couple choices. We can move the exponents that are negative so that they become positive, or we can simply combine the ones that have the same base. Again, totally a matter of what you like. Since we did the last one by just subtracting the exponents, let's do this one by moving the negatives around just so you can see, and then you can decide which way you like better. So anything with a negative exponent, we're going to move to the opposite spot, right? So if it's in the top, we'll move it to the bottom. If it's in the bottom, we'll move it to the top. So I'm just going to go over here because I know I'm running out of room. All right, so which one am I going to leave? This one is going to stay where it is, right? Because it already has a positive exponent. Now everything else we're going to flip. So the x to the negative 16th is going to go down to the bottom. And it doesn't matter which order, right? Which one comes first or second. The y to the negative second is also going to go to the bottom. And then what happens to the y to the negative 8th? That goes to the top and becomes y to the positive 8th. Okay, now we still have more to do, right? So now we have to combine because we have a y written twice and we have an x written twice. So let's start with the x's. I can combine these two because they have the same base. In order to combine these, since we're multiplying them, what are we going to do with our exponents? So that was our very first property. If we multiply powers with the same base, we will add the exponents. So those are going to stay where they are since they're in the bottom. If I add 2 plus 16, I get 18. And then to combine the y's, so we're going to combine these two now. And we're dividing those, right? And we said that when we divide powers, so that was our second property, divide powers, with the same base, we are going to subtract our exponents. So that would become 8 minus 2, which is just 6. And that should be your final answer. Okay, so you've got practice assignment, 2 of them for this week. I hope that that made good sense. If you have questions, then certainly we've got a couple Zoom meetings this week, and feel free to email me anytime if there's something else you need.